Hello everyone. In this lesson, we're going to explore real-world linear functions by using the rate of change and the initial value. Rate of change means slope. Initial value is the y-intercept. So when you hear those words, don't get fooled. Rate of change, slope, same thing. Initial value is the starting point, the y-intercept. All right, so in the do now, you have to find the slope and the y-intercept of the following linear functions. Just remember, it has to be in the y equals mx plus b format. That is the slope-intercept form, and this one is in y equals mx plus b. We are going to put a 1 in front of that x. That slope is 1 and the y-intercept is 12. So remember, this is the m and this is the b. This one, number 2, is not in that format, so that means we have to solve for y. So I'm going to add 5 on both sides to solve for y. This cancels, and then we're going to have y equals, we're going to put the 3/4 x first, plus 5. So that is y equals mx plus b, and the slope is 3/4, and the y-intercept is 5. For number 3, that is not in y equals mx plus b format. Again, we are going to solve for y. So we're going to add 4x on both sides. When we rewrite it, though, please put the x first. It's not wrong if you don't put the x first, but what I mean is that we are going to put 3y equals 4x plus 3 instead of 3 plus 4x. It doesn't matter, like you're not going to get it wrong. It's just that you're setting yourself up to now divide by 3 on both sides. This cancels, and then you get your y equals 4 divided by 3. Keep it. Keep that fraction. Rise over run, 4/3. And 3 divided by 3 is 1. So the slope is 4/3. And the y-intercept is 1. And that is it. Just remember, you have to solve for y. To get the slope and the y-intercept, must solve for y. Solve for y. All right, which one has the steepest slope from the ones above, the linear functions above? So you're looking for the slope that is the furthest away from 0. And that furthest away from 0 is 4/3. So remember, the furthest away from 0 is your steepest slope. So we have 4/3. We're not going to write in highlighter. We're going to write in blue. So line 4/3, line 3. All right, so here's the launch. Using your knowledge of slope and rate of change, answer the following questions. Choose 2 points and find m. So we're going to find the slope. I'm going to talk about this one right here. This is a nice line, this 1 point. And then this is my second point. So I'm going to do the rise over run. So rise over run is your slope formula when you have a graphed line. Nice and easy. So my run, which is what is going from left to right, is 2. And I'm going to put that number there. And then my rise is not 1. Just remember, it's going by 4s, the y-axis, so it's 4/2. So it is 4/2. And the slope is 2/1. I'm going to reduce that. And just remember, the 2 represents 2. The 4 represents I'm sorry, 2 represents minutes and 4 represents dollars. So the Y represents dollars and the X represents minutes. And I put that in, this is dollars, so I'm going to put $2 over 1 minute. So what does the rate of change show? It shows that this phone card costs $2 per minute. So it shows that the phone card, it costs $2 per minute. And remember, the rate of change, we're talking about rate of change here. And rate of change, when you see those words, it is slope. All right, so we're talking about slope. And if I can get this to highlight, that would be good. Rate of change is slope. Purchase fee is y-intercept. So we're talking about the y-intercept when we're talking about the purchase fee. And so that right there is shown on the graph. So can you see the purchase fee on that graph? And it's right here. That is the purchase fee. The y-intercept is the initial fee. It's the purchase fee. All right, and the card is a purchase fee. What is that fee and how is it shown on the graph? It is $4 and it is the y-intercept. An initial value. All right, explain your answers in your own words. How do you recognize a linear equation? Well, you recognize a linear equation in that it is in the format of y equals mx plus b. And so how can you draw its graph? Just remember, recognizing a linear equation is just y equals mx plus b. It has to be in that format. If it's not in that format, it is not linear. How can you draw its graph? Well, it's a straight line. That's all it is, straight line. Write an equation that is linear, then you can basically make up anything in y equals mx plus b format. You could have y equals 3x plus 10. You can have y equals 1/2 x minus 2. You can have y equals 5x. That is a direct variation. Just remember, all of those are linear equations. Right? Write an equation that is not linear, non-linear. That's what it's called, not linear, non-linear. So this is not an equation that is in y equals mx plus b. So there are a couple of different equations that are non-linear. So if you put y equals x squared into your calculator, just to do this pretty quickly, hopefully, y equals x squared, you could see that this is not linear. It's a parabola. So that is a non-linear function. So to go forward, we can have y equals 3 over x. Let's see what that comes out to be. If you graph it, that is not y equals mx plus b. So I'm going to do alpha x and I'm going to put that and graph it. And you could see in red that it is non-linear. So there's a couple of others that you have. You could have y equals 3 to the x power, where the variable is the exponent. You cannot, you can't say that that is y equals mx plus b. So I'm going to put 3 to the x power. That's how you put that in. And you could see that in the black line, it is non-linear. more, you can have y equals square root of any number, which is 10. Not any number, but a non-perfect square. Square root of 10, or square root of x. Let's just say that. Square root of x, and then we're going to go ahead and graph it as the fourth. So we're going to go second function, square root, and we're going to put x in. And we're going to see what that brings, and there it is. That is a non-linear function. Non-linear function. And one more, we have y equals absolute value of x. All right, so we have that y equals absolute value of x. We're going to graph that, hopefully. No. And I finally got that down there. Y equals absolute value of x. We're just going to bring up the calculator again. Go to Y5, the fifth line. And you notice that there's no absolute value bars anywhere here on the calculator. You press math, and then you go over to num. And you see this ABS. That stands for absolute value. So we're going to press 1. And we are going to put x in there. Just make sure that you press to the right and get out of the absolute value bars. And you could see that the absolute value of x is a V shape, which is non-linear. So all of these are non-linear. It's not y equals mx plus b. Anything that you're talking about y equals mx plus b is, and it has to be in y equals mx plus b format. So the next question asks, which one is parallel? Write a linear function that is parallel to this. Just remember y equals 3x minus 4 is linear, and you have the slope of 3 and the y-intercept of negative 4. To write something parallel, it has to have the same slope, different y-intercept. So we have y equals same slope, different y. It could be anything. It could be 5. And I'm going to put 5 down. Remember, same slope, different y-intercept. And that's about it. All right. So we're into John's savings account. And we are going to go and identify the initial value. The initial value, remember what I told you before, the initial value is the y-intercept. So we're talking about the y-intercept right there. The y-intercept is b, so I'm going to put it as b, and b equals 300. And that is dollars, so the numbers, it's just the amount that John has in the savings account as an initial amount. Right? Initial value is the y-intercept. The rate of change is the slope. So that means you have to do some rise over run action here. So I'm going to put that down. M equals rise over run. M equals, and I'm going to go and pick another point, which is this one. So I'm going to put this in red because I need it to stand out, because it's a very small triangle, which is good because if the smaller it is, the better it is. You don't have to reduce a fraction. You don't have to worry about counting wrong. As far as if you pick this point right here, this first point, and this last point, you have to count across the whole graph. There's more of a chance that you are going to get something incorrect. But for this, you don't have to count across the graph. It's just 1. And then this is not 1. It's going by hundredths. So just remember, I'm going to put 100 here. So we have 100, and that is $100 over 1 month. So write the equation of the line is y equals 100 x and plus 300 is the y-intercept. Use the rate of change to calculate how much money John will have in his account in 15 months. So all we have to do really is to substitute. We're going to substitute 15 in for x. So we're going to have y equals 100 times 15 plus 300, because x represents the months. So we have 15 months that we're going to figure this out. So John is going to have $1,800 $1,800 in his account at 15 months. And we used that rate of change to calculate that. All right, and that is about it. All right, so here we go. Here's $100 in the savings account and plan to deposit $15 each month. I'm going to do some highlighting. Depositing $15 each month. So with the way you set up the graph, if you set it up this way, you will never get anything wrong. Just remember, you do need to identify what the X represents and what the Y represents. Just let me get this down to 300. No. 200 is good. So I could move up there. All right, so write and graph a linear equation that represents the balance in your account. So the M is 15 over 1. And that's $15 per month. The B is 100. So what we're talking about here is on the x-axis, we're talking about months. So I'm just going to go and put months down, and I'm going by ones. Okay, on the y-axis, I'm going to go by money. But I have $100 in the account to begin with. So I don't need to see anything before 100. So I'm going to start with 100. I'm going to go up to 100. And since I'm starting at 100 and then increasing by, guess what? 15. I'm not increasing by hundreds. Because if I increased by hundreds, the next month when he puts $15 in, guess what? You're not going to see it. So this person is putting $15 a month in, so we're going to go to 115. And then the next month is 130. We always rise by the slope. This is 145. 160, 175, and you put them right next to the line. 190, 205, 220, 235, and you end up with $310. All right, so now that you set this up this way, just remember this is dollars, the y-axis. And these are months. And I'm going to put a title, bank account savings. Now look how easy this is to actually graph now. But I am forgetting something. Since I went up by hundreds, since I went up by 100 in the beginning, and now I'm going increasing by 15, that's a different amount. So what you need is called a break. So it's like a little lightning bolt. So this is needed right here to show that you're skipping up to 100 and then increasing by a different amount. If you went up by hundreds, say if you went 100, 200, 300, 400, you would not need a break. It's the skipping up to the number and then increasing by a different value that that enables that, like you need that break because of that. All right, so here we go. So at 0 months, this person has $0. No. At 0 months, this person has 100. This is the starting amount. Initial fee. So that means I'm here. Starts at 100. So now we're going to rise 15 and run 1. And then we could just go up like this. See how easy the graph is when you set it up by slopes. I'm not even looking at the numbers. I'm just going up, rising 15, running 1. Every month that goes by, you just add another $15 to this account. And we are going to go and connect those points. We're going to go past the last point and put an arrow. Write and graph a linear equation. The equation is y equals 15x plus 100. We're going to put that directly on the line. And that's it for A. How many months will it take you to save $205? Well, we can just go ahead here and say, okay, here's 205. And I'm going to go there to the line that I drew. And I'm going to go straight down. And then I use the graph 7 months. And that's your work that you showed. You used the graph to do it. You didn't use the the equation that you had. But if you substitute y equals 15 times 7 plus 100, you would have 205. So that is how you put your graph together. All right, so here we go with the rate of fuel leakage, and we have the initial value at 18. There's the initial value, 18 gallons. The rate of change, what I'm going to do is I am going to use this point right here, or I could use this point. It's okay, but I'm going to use that point because it's really close. So I'm going to go -2, and then this is 1. So the rate of change is -2 gallons per minute. And the y equals mx plus b, the slope-intercept form is -2x. Plus 18. So what if the tank were leaking at 3 gallons per minute? Now we are changing, right? The amount of leakage that's actually happening. So if the tank was leaking at 3 gallons per minute, describe how the graph would change. I'm going to go ahead and graph it. So 3 gallons per minute would be down here to 15 and right here. 3 gallons a minute from 15 would be 12, or a decrease of 3, and a run of 1. Down 3, run 1. Down 3, run 1. Down 3, run 1. Down 3, run 1. So this is how it would change. This is the exact way that the graph would actually look. Let me put this in a different color. Just like that. No arrows needed, by the way, because you're out of fuel right here. There's no more. The tank is empty at 6 minutes. With the tank, would describe how the graph would change. The line would be steeper, as you could see when I graphed it, and because the loss of fuel has increased by a minute, now it's leaking at 3 gallons per minute instead of 2. And the tank will be out of fuel at 6 minutes instead of 9. So that is the difference. And you could see that the line is steeper because that slope has increased. Right, so try this. Do the points. Let's see. -2, -1, 1, 5. C is 4, 11 lie on the same line. Without using a graph, how can you justify your answer? So there's an easy way to do this, even without a graph, it has to do with patterns. The pattern from X to X has to remain the same if it's on a line, a straight line. So I'm going to go and see what the pattern is here. So from this X to this X, that is a +3. And then from this X to this X, that's a +3. That's good. So let's talk about the Y. This Y to this Y is +6. And then this Y to this Y is +6. So are they on the same line? 1, 2, 3, 4. They are. The pattern is the same. All right. So if the pattern is the same, it's a straight line. Without using a graph, you could tell about patterns. And if that pattern is different, that means it's not on a line. Like, in other words, if this was, say, 4, 13, then it would not be, because the pattern would not be +6. And here's the official answer. The pattern for each X value is +3, while the pattern for each Y value is +6. The pattern remains constant, so we can say that all of the given points are on the same line. And that is it. I would have graphed it just to make sure, but I mean, with the pattern, you can definitely tell that they are on the same line. So here is another graph here. Rate of change. It asks you for the rate of change right away, and I'm going to skip this. You see this is like 25, but I'm not sure if it's 25. So I'm going to go up to a perfect point, and that is a perfect point. And my next perfect point is here. So for the rate of change, now obviously I'm going to do rise over run. Remember, rise over run. I'm going to be careful about counting because, again, these are going by ones, so that is 2. These are not going by ones. The Y is going by 10, so 10, 20, 30. So we're going to have 30 over 2. Rate of change, which is M, equals 30 over 2. And that equals M equals 15. And remember, these are dollars. And let me just see what, no, it's over weeks. So $30 in 2 weeks and $15 per week. The initial value is easy to see. The initial value here is the y-intercept. The y-intercept is 25. So we're going to put this together in y equals mx plus b as y equals 15x plus 25. So this is the amount of savings per week in Will's savings account. Shows the amount of money in this account. Why doesn't the graph start and begin at 0, 0? Well, pretty easy. Will had money. He had $25 at the beginning before he started saving. So he starts at this 25. That's why it doesn't start at 0, 0. And there it is. Okay, so Sal earns $15 per hour selling books, $15 per hour. So we're going to put everything here first. We're talking about dollars. And we're talking hours. Move this down. The rate of change is $15 per hour. So we're just going to put 15 over 1. We're going to rise and run. The initial value is 0. Because Sal earns $15 per hour selling books, if he works 0 hours, he gets $0. So the equation is 15y equals 15x. And you could see this is the first direct variation that we are going to graph. And it says graph the function. So let's put some numbers down. So we are going to go 0, 1, 2. We're going to count by ones for the hours. And then we are going to go and increase by 15s. $180, $195, $210, and then $225. All right, so we counted by 15s. We do not need a break. This is where you are consistent. You are skipping up to 15, but it is consistently skipping by 15s. So 0, 0 now, this is a direct variation. This is where it starts at the origin. It's rise of 15, run of 1. So we are just going to go up just like this. I'm going to move my face up. And then we are going to, let me go over here, try and pick a nice color. Draw a nice line connecting those points. And we're going to put y equals 15x on the line. And that is the graph. So just remember, when you're like the hours, like weeks, months, usually independent variable, you're going to go by ones, usually, not all the time. But now the dollars, that's the y, it's the dependent variable. You're going to go by tens, maybe hundreds. whatever it is. You look at the rate of change. It is 15 in this case. So that's why you're increasing by 15. So just remember, this is what you're going to use. That slope is what you're going to use to determine what your y-axis is going to look like. If it rises 15, there's no reason for you to go by ones. There's no, like, you want some data on the graph. So this is the way you would do it. So just going on, a salesperson earns $12,000 per year and 500 per phone sold. So this is for 1 year. So what is the initial value? It is 12,000. So they earn $12,000 before they sell a phone. And then the rate of change, which is the slope, it's $500 per phone. And if that is a rate of change of 500 and a 12,000 initial value, remember initial value is your B and the rate of change is your M. So y equals mx plus b is y equals 500 x plus 12,000. Not bad. All right, so we're going to go a little, back and forth here. So we are going to, this is, again, the y-axis, dollars. And the x-axis, in this case now, is phones. The title. Actually, I'm just going to put salesperson's earnings. Salesperson's earnings, that's it. Okay, so phones. We're going to just go by ones. Okay, I'll lift that up again. Okay. It'll go up to 15. Okay, so now this is where, like, you have to, what do you go by, right? So the rate of change is 500 per phone. So shouldn't you start at 500? No, you start at the initial value. So the B is the initial value. So we're starting at 12,000. Now, after the 12,000, you're increasing by, you're using the slope. So it is 500 per phone. Rise of 500, run of 1. So it's 12,500, 13,000, 13,500, 14,000. And you go up just like this because your initial value is the 12,000. That's what the salesperson gets paid if he sells or she sells no phones. So why put down 500? Like you'll never see it. Like you'll never, like it doesn't matter. It's not going to be any graph. There won't be a graph if you start at 500. Because the least that this salesperson can make is 12,000. And it goes all the way up to 19,500. So let's see. Nice and easy graph. We're going to start at 12,000, starting point. So we're going to start right here. And look, did I forget to have my break? Yep, I have to have a break. And the reason why I have to have that break is because I'm going up to 12,000 and I'm increasing by a different amount, which is 500. So for one phone, 12,500. 2, 3, and now you don't even have to look. The corners of every box. Just like that. Connect the points. Put your arrow. Put your equation on the line. $12,000. And that is it. Not terrible, right? You remember, you begin at B, initial value. Then you move with the rate of change, the M, rise 500, run of 1. That's what you're going by on your graph. Okay, so now we don't have to graph this, and we just have to write an equation using the rate of change in the function, the values for each function to help. So the rate of change right now is, we don't know what that is. So we're just going to put x1, y1, x2, y2. We don't have a graph, so we're not using rise over run. We are using y2 minus y1 over x2 minus x1. So I'm all set up with y2 minus y1 over x2 minus x1. That is 125 minus 75, y2 minus y1, and 1 minus 0. So when you put this directly into the calculator, you will get 50 over 1, which is 50. Let me just put that down a little bit neater. So it's 50. Okay. The initial value is here, so you could see this one, they went easy on us. There's the initial value, 0.75. So B equals 75. The linear function, the equation is 50x, y equals 50x plus 75. And that is it. State a reason why the first value is 75. That is the initial value. Is 75. Is it dollars? I don't even know. But I don't care. The initial value is 75, so that's why it starts at 75. So write an equation that represents this. Okay, here we go. Rate of change. I'm going to start at x1, y1, x2, y2. And so I have my formula down, y2 minus y1 over x2 minus x1. We have now my y2 is 180. Okay. Minus 240. And it is x2 minus x1. Now I'm going to bring up my calculator for this. I'm going to put this as a smaller screen here. And remember what I told you a million times. Please just put the entire thing in. Alpha x, you're going to put the numerator in first. Don't do it separately. Let the calculator give you your answer. And then 6 minus 4 as the denominator. It is negative 30, so m equals negative 30. All right, initial value here, a little bit difficult to see. Remember, we should use the point slope formula to get the initial value because we are missing the y-intercept, or we could do something with the pattern of the table to get where the x equals 0. So I'm going to use the pattern. So if this going backwards, if it's going backwards, it's decreasing by 2. That's minus 2 decreasing. So if it's minus 2, that is 2. If it's minus 2 again, that's the 0. And that's where we want to be. Because your x is increasing by 2 all the way down, if you go backwards, it's minus 2. So if we go backwards, 180 to 240, that is plus 60. And if we go up backwards again to plus 60, that's 300. And then one more time, plus 60, that would be 360. So 0, 360, initial value 360. The linear function is y equals, the equation in slope-intercept form is y equals negative 30x plus 360. So this is the linear function. I'm going to describe it. The linear function has a negative slope, so the line is going down from left to right. It has an initial value of 360 gallons. This is a reservoir of water in the reservoir and will be empty at 12 hours. You see right here, it is 12:0. Okay, there we go. Right here. That means, though, that is not the y-intercept. That's actually the x-intercept, where it hits the x-axis. But we didn't need that. But it is nice to see. Well, it's not nice to see, but if it is there and on the table, that means at 12 hours, there's 0 gallons left. So that's how you read that graph. And that's exactly what I put for the description. All right, let's talk baseball. Productive struggle. Card collector purchases 5 baseball cards. Let y equals represent each card's total and x represent the number of years. So x represents the number of years since purchase. By the way, y always represents the total. All right, so which cards are decreasing in value each year? So decreasing in value each year. Decreasing means negative slope, negative rate. So anything with a negative rate, that is a decreasing value. So negative rates. So card A is decreasing in value. And let's see, any other decreasing in value? Yes, card D. So, and card D. So just remember, you have your negative rate, and that's exactly why that those are decreasing in value each time. All right. Which cards had the greatest initial values at purchase? So we're going to talk about the B, the y-intercept, the greatest y-intercept, the greatest B. So we're going to put which card or cards has the greatest initial value. So this is 5. So I'm going to label B equals 5. B equals 4. Card B is out. B equals 10. B equals 8. And B equals 10. So we're going to say card C and card D. C is 10 and D is 10. And that is it for that question. Pretty easy stuff that we're talking about there. All right. So for number 3, which cards are increasing in value the fastest from year to year? So you're looking for the greatest slope. So the slope right here is the M. Let's go and put M. No. M equals negative 0.7. The M here is 2.6. That's a pretty good thing there. M equals negative 1.1. That's not increasing. And then this one is M equals 0.25. And this is M equals 0.9. So 2.6, card B is increasing the fastest, and it's only one card, so card B. Increasing the fastest from year to year. All right. All right, so card B is increasing the fastest. So between card B and card C, which line, if you were to graph them, would be steeper? So this is y equals 0.9x. This is x plus 10. So which one would be steeper? And card B would be steeper, and it just kind of, you look at it and say, okay, card B is steeper. It has the slope that is furthest away from 0. And that is it. And there it is, card B, 2.6, further away from 0, the slope, and that means that the line would be steeper than a 0.9 slope. And that is it. So the exit slip, here we go. Tara creates a budget for her weekly expenses. The graph shows how much money is in the account at different times. You can look at your graph. That's a negative slope. Find the slope. As soon as I see this, I know that this is a negative slope. And it's because it goes down from left to right. You could put your L and your R here. It is going down. So that means this is a negative slope. So the slope is negative 50. The slope is negative 50. The slope is negative 0.02. This is out. All right, so here we go. The slope is negative 50. Let's see. So I'm going to go and I'm going to just go and put x1, y1, x2, y2. It's the first thing that I'm thinking of. So this right here is now my y2 minus y1 over x2 minus x1. So let's see what this slope is right away. You have your minus signs right there. You have 2,000 minus 2,400 and 12 minus 4. Now you know that it has a negative slope. So I'm going to put 2,000 minus 2,400 directly into my calculator as the numerator over 12 minus 4. Now I know that's going to come to a negative number, or it should. It is negative 50. So the m is negative 50. So that means this is out. So here we go. There's only 2. So the slope is negative 50. And the slope is negative 50. The slope means the amount of money in the account is decreasing at a rate of $50 per week. That sounds good. The slope means the amount of money in the account is decreasing at a rate of $50 every 2 weeks. That is out. Remember, the slope is $50 per week. So that means not every 2 weeks. A rate is to a unit of 1. So we're talking about $50 every week. So A is your answer, and that is how you would do that. All right. The challenge problem, explain why the graph to the right would never represent the rate a cab company charges. So obviously, this is probably money right here. They don't give you any numbers, so just looking at a negative slope, that would never have a negative slope, because that means that the cab company is charging less and less as the miles. Maybe these are miles, I'm not sure. A cab company's like the total cost is increasing, it wouldn't be decreasing. And that's exactly what I put there. The charge would be increasing rather than decreasing, so you're not going to have a negative slope. And that is basically it. The charge would be increasing rather than decreasing. So the slope that we're talking about, the slope of the line, would be positive and not negative. So it would be going up, not down. And that's it. All right, and that ends our lesson. We're on our summary. And so just remember a couple of things about, let's go back to this right here. When you're talking about a graph that you're creating the graph. Let me just go this one because this is a better graph. You're using that slope to rise, and that's really it. Like, you know, so you're increasing by 500 here, but the initial value is 12,000. So you start at your initial value and you increase, and label your graph using the slope as the rise. So if the rise is 200, that's what you increase by. And that is it. All right. Thanks for watching, and I'll see you next time. Bye, everybody.